Okay, we're now going to have a look at series. So series are not when you just have the terms, they are instead when you decide to add them together. Okay, notice the addition signs between. So chapter 3 of this book has a couple of different series. We have arithmetic and geometric. There are other ones as well that you will learn later in the book, but it's when we add the terms together. Okay, it's about adding the terms together. On the left-hand side, this one here you learned in the previous lesson. This one is in the formula booklet, and it's about when you want to add the terms together. So I've just borrowed the example of 2, 5, 8, 11. Let's imagine we want to stop there, such that we want to add the first 4 terms. Well, if I put these into this formula, this is the same a, n, and d that you already know, then I should get the answer. 2a means 2 lots of 2. n minus 1 is 3. 3 lots of the difference, which is 3. Okay, and that should be the same as if I add those all together. So 4 over 2 is just 2. 2 times 2 is 4, and that's 9. 4 plus 9 is 13. 2 times 13 is 26. Okay, which is the same as if you do this here. So you can use this in the formula booklet, like I said. However, you will be expected to be able to prove where it comes from. Before we do that, though, let's have a go at a few quick examples. Notice the addition signs. Find the sum of the first 30 terms of each of the following arithmetic sequences. So on the first one, we've got a as 2. We've got the difference as 3. And we would just substitute them into this formula. Okay, so I'll do one with you. So the top one, we said that a was 2, d was 3, and n was 30. So you write out this rule here, and then you substitute the values in. So the sum of 30 terms, that's what that means, is 30 over 2, 2 lots of 2, plus n minus 1. You can write this as 29 straight away if you like, or you can do 30 minus 1 like that, times the difference, which is 3. Close brackets, close brackets, square brackets. Right, and if you type that all into your calculator, you will get your answer. So notice now that we're kind of answering questions which you wouldn't be able to do, you know, in just like 30 seconds or something, okay? If you had to write all of these terms out, it would take you a long time, because that is what the first 30 terms added together are. Okay, something to watch out for this one. So the difference is a negative number. If you have the difference is a negative number, put it in brackets like I've done here, and you'll be safe with it. Okay, so I think I'll just write it out for you, just out of interest, in case you want to see what it looks like. That would be 100 over 2. 2a would be 2 lots of 100 plus n minus 1. So n is 30 again, so 30 minus 1, and the difference is minus 2. So from experience of marking a question just like this in the real exam, I can tell you that that is the worst answered part, is forgetting that negative. So be nice and careful with it, please. Your answer to that is going to be a big number, yes? I will leave that one for you to work out. We're going to have a go now at the second part, though. So the second part is more difficult. So find the minimum number of terms. So the smallest n is what that means. Find the smallest n so that a sum, so sum means we are adding, remember? So a sum like this is bigger than 2000. You got some hints to have a go at if you want to pause and have a go. So the rule, remember, is n over 2 square brackets 2a plus n minus 1d. Okay, State your values like you do with the discriminant and other topics like that. A is 4, D is 5, N is, well, that's for you to work out, yes? How about the 2000 thing? How would you handle that? Well, what you're really asking me here is you're saying, when is this sum bigger than 2000? Okay, so you're working with that bit there. Yeah, the sum being 2000, or in this case, I've said the sum being bigger. So you can do it with an inequality sign. N over 2. So N over 2 is N over 2, because that's what the question is. You're trying to find the N that makes this thing happen. 2 times 4 plus N. Again, you don't know what N is. That's what the question's about. The difference, though, is 5. Okay, and we're going to work this one forwards. So a good next step. Again, this is a super common exam question. So if you were listening to me talking about this one here, on the same question, I remember marking one just like this. Okay, it was a show that question. So for a show that question, exactly as we're doing on the board. So 4,000, I'm going to keep the N there, and I'm going to simplify this as an 8. 5N, I'll write that bit as 5N, and I'll write that as minus 5. Okay, and that is okay. In fact, you could then do something like this. That's still fine. It's easy to see where all the workings come from. So 4,000. Let's expand this now. So 5N squared plus 3N. Okay. Move this part over to the other side. You get 5N squared plus 3N minus 4,000. And what you have then is you have a quadratic inequality. Okay, so remember that a quadratic inequality, N squared is a bit like X squared, is going to look like this. Okay, so you're going to use the calculator now to find out what these roots are. I'm assuming one's positive and one's negative, but it doesn't have to be like that. And it's also worth remembering that N must be a whole number. Okay, so for example, I'll leave this one to you because I don't have the calculator in front of me. But if you get an answer like N is a negative, first of all, that's always nonsense because you can't have a negative position in a sequence. But if you get also an answer like, let's say, 27.2, how do we interpret that? Well, when you have 27.2, that's when the sequence will be bigger than 2000. So the answer then would be, for example, 28, because you would round it up. Okay, I leave that one for you to finish. And that's essentially it. Okay, so there's a test your understanding question to have a go at as well. You will have a mixture. You will have a mixture though of nth term and the sum. Okay, so you're going to need to be careful about which one you need. Sometimes you need the top one. Sometimes you need the bottom one. The top one is just a piece of the sequence, a single term. The other one is for when you want to add them together. And in the formula booklet, this is what it looks like. Okay, so it's written exactly as is there. This is quite useful because if you look at this version of the sum, you can actually see the nth term hidden inside. Okay, the nth term is actually just that part there. So that's quite a useful trick to know about as well.